So in this problem, this is homework 16, number 6, we want to find critical points and then whether each critical point corresponds to a local extrema, and then also the absolute extrema over the interval from -4 to 5. So unfortunately, this involves solving a cubic, which I certainly did not intend to assign, so you're going to have to do it using a graphing calculator, because I am unable to unassign it, unfortunately. So we're going to start by taking the derivative. So f prime is 24x cubed minus, actually you can probably do the whole problem without the derivative, but let's do this anyways, minus 16 times 3 is 48, 48x squared minus 222, x to the first plus 120. Okay, so what you're going to do is go to your calculator, and you have a choice here. You could enter the derivative into y1, and then try to figure out where this derivative equals 0 by using the graph of this and seeing where the function itself actually equals 0. I think what more of you will do, though, is you will graph the function. So here I've entered 6x to the 4th minus 16x cubed minus 111x squared plus 120x plus 29. Okay, and I want to graph that. Now, when I just go straight to the graph, I'm not going to get a good picture. Yeah, that's horrible. We need to be able to see the maxes and the mins. Okay, so we need to adjust the window. I know I'm really only going from -4 to 5, but I'm going to take this a little bit wider and go from -6 to 7 and add 2 units on each end of that. For my y's, I don't know yet. Let's go look at the table. Okay, enter. I guess I have to enter something. Hang on. Okay, I'll come back to this. So let's go to the table. There we go. I want to look at the y values as x goes from about -4 to 5. So it looks like the y value starts at 333, then it goes down here to -400 and something, up a little, then down. Looks like the lowest point is -550, or no, -755 is the lowest number I see. When x is 5, -496, and then when x is 6, it goes way back up. Let's go from maybe -1,000 to 1,000 just to be sure we catch it all on my window. So for my y min, that's probably too wide, but at least we'll see it all. Let's go from -1,000 to +1,000. We'll go by 100s, how about? Now let's try it again. I don't think I entered my x's right. That doesn't look right. My x-axis. You can see what I put there. -6. Oh, I meant to put -6 to 7 to give myself a little extra room just to make sure I can see the whole thing. There we go. Okay, now I can see what this 4th degree polynomial looks like. And yeah, we can see the 2 low points. Those are the 2 local minimums, and the high point, the local max right there. So first, let's figure out whether the critical points correspond to local maxima, minima, or neither by using just this. And actually, we need the critical points first. So we're going to find the critical points from using the graph. Clearly, there's 3 critical points. When you solve a cubic, you would get 3 answers if we knew how to solve that, which there are techniques to do, but it's pretty hard. So anyways, at the 3 critical values, the derivative is going to equal 0. So that x value right there is a critical value, that x value is a critical value, and this x value is a critical value. So we're going to find them all by using calc, and we'll do the min and max functions. So we're going to go to min. So I'm going to go to the left side of this first minimum. Okay, and hit enter. Now it says right bound. Let's come over here to the right side and hit enter, and then hit enter again to get the minimum is x is -2.5. Okay, that's one of the critical values, and let's go ahead and make note of that y value as well because we may need that. So -480.375. So f of -2.5 is -480.375. It sounds like it's probably exact, but I'm not for sure. Okay, then we need to go to calc and do the maximum. Come over here to this little local max. Okay, that's on the left side of the max. Then we go to the right side of the max. and hit enter again. I wonder if that's supposed to be a half. That sure does look like it. I have a strong feeling that that's supposed to be x is 0.5 and that my calculator's rounding. I'm actually going to try it again and see if I get the same or a different answer. Do max. Okay, left bound, right bound, enter. No, same thing. I'm going to go with x is a half though. And f of 1/2, f of 1/2 is 59.625. Okay, and then the last one we're going to need also is a minimum. So we've got to do the left bound. And the right bound. Okay, that's supposed to be 4. So x is 4, y is negative 755. So that's my third critical value is 4, and f of 4 is negative 755. Okay, so those are the 3 critical values. My calculator was just a little bit off in the decimals, but anyways, those are my critical values. So you would enter those in. Then it's going to ask for part B whether each critical point corresponds to a max, min, or neither, which you can just read straight off the graph. Those two are minimums. This one's a max. And then find the absolute min and max values on the given interval. So that's where you compare y values to see what is the single highest y value for your absolute max and your single lowest y value for your absolute min. So we would also need to find f of the endpoints, -4, and f of 5, which you can maybe do from the graph, or you can just type in, like plug in -4 and 5 manually, and then compare all these values to get your absolute max and min. So hopefully that helps on that problem. Again, if you don't have a graphing calculator, I'm sure you can find one online or borrow one from a friend for this problem.